Welcome to Risk Roundup. Intelligent autonomous systems are here. Its emerging potential is enabling entirely new capabilities to human environment and ecosystem where direct human control is not physically possible. Now, since the underlying technology of any intelligent autonomous system is capable of adapting to changing conditions, knowledge, and constraints, it is also possible to assign very broad objectives to them. As a result, new ideas and initiatives are emerging rapidly across industries to explore the capability of such autonomous systems. To discuss autonomous systems further, I'm delighted to welcome Nadia Ahmed to Risk Roundup. Dr. Nadia Ahmed to Risk Roundup. Dr. Nadia is a professor in computer science, and she's also a faculty advisor in machine learning at Saddleback College based in the United States. Welcome, Dr. Nadia. We're honored to have you on Risk Roundup.
Thank you.
Wonderful. So before we begin discussion broadly on the autonomous systems, let me ask you, what research problem are you working on?
So I work on energy efficient buildings, so smart intelligent buildings. I work on essentially how can we optimize the scheduling of appliances in a way that does not interfere with the comfort of the consumer that lives inside of it, and also takes into account weather patterns, how much energy that you may be harvesting on your solar panel, your rooftop solar panel, and takes into account if you decide to have any kind of energy harvesting, energy storage device sort of connection in your home, similar to what Tesla proposed with the Powerwall. So that's been my line of research for the past several years. It's been since 2014. Prior to that, I was working in smart meter technology. Majority of my life, my theme has been focused on energy efficiency because energy is a major problem in the United States, as is other environmental concerns like climate change. And I think that as we progress into the future, those are going to be more and more relevant to today's society.
Yes, absolutely. Those are at the very core of every nation's economy. Now, when you talk about the smart buildings, you talked about you worked on the smart meters also, and also smart, buildings and smart energy. So, are you working towards Internet of Energy?
Yeah. So there is this concept of IoT within the home, where each of your appliances are smart appliances. They talk to each other, and there's a central hub called the Home Energy Management System that takes into account all of the appliance energy patterns, human behavior. Actually, the core to my research is that you keep it centralized on the consumer, because the consumer is really the motivator for what particular appliance is going to be turned on at any given time, the principal motivator for how energy is going to be utilized. So really understanding human behavior in a very minimally invasive way is really important, because people are really concerned about their privacy. Absolutely. So how can you have this IoT connected home that, in a sense, has to monitor the behavior of the consumer, but do so in a way that's non-invasive, that the consumer can trust, and that makes their life convenient. So there is this trade-off of convenience and privacy. And I think the reason why, so my particular area of research is in residential demand response. And prior to that, demand response programs that utilities were using were not being very widely welcomed, because people are not open to having a big company come in and take control of their air conditioning unit, for example. Yes. In the industrial sector, it's not necessarily a problem. They're willing to, we want to cut energy costs. We want to work with the utility, and they're open to automated demand response programs. But in the residential sector, which accounts for about 22% of energy used, they're not so open to it. So how can we make a fully integrated framework that they can be willing to take on, that incorporates parts of their life and schedules appliances in a way that they're not even aware of, that in the end of the day minimizes their energy consumption bill.
Sure. Now, the point that you made, that you're keeping the consumer at the center, but at the
Right.
same time, we are seeing that we are moving towards decentralized economy, and especially when you talk about the energy systems, when we are trying to, when the consumer is, on its way to becoming the supplier of energy, especially when, with the solar panels on the rooftop, and every each and every consumer, is going to end up not just producing energy for themselves, but also they will have surplus. So yes, many of them will store that for their use, but many of them, in the coming years, will also supply that to the grid. So it is not just the demand that we will have to focus on. It's going to be both, demand as well as, supply. And
Mm-hmm.
that is why, the whole energy ecosystem that we are developing is going to be very interesting, because it's not, we are moving away from the centralized grid to, decentralized grid, so that, it's actually very beneficial, because then, no matter if there is any attack, terrorist attack or anything, they cannot take the entire grid down, because the grid is not just in one place. The grid will be everywhere, and they cannot take the, everybody's system down all at the same time. Of course they can, but it will be much, much more difficult. So it's going to be very complex, how we develop this energy system. And as we move towards automating, or creating autonomous system, especially for these energy industry, if we are talking about, smart energy, it's not only smart grid but smart energy, then what role do you see this autonomous system playing for the energy industry in the coming years?
Well, I think there already is, to a degree, a lot of autonomous integration that has happened over the years. If you think about it, the current energy grid was built like in the 1920s, earlier in the century, and we've been working since computing has improved so much towards increasing the smarts of the smart grid, if you will, both in the generation level, the distribution level, and in the residential level. Now, you are dealing with a very conservative industry.
Yes.
So that's the one thing that's why the growth hasn't been as fast paced. You also have an extreme scarcity of power systems engineers. So there was a period in, I think, around the 90s where power systems engineers were not so much in demand. And as a consequence of that, fewer and fewer people were power systems operational research engineers. And so a lot of the operations research that occurred happened more in computer science and shifted over into this new term, machine learning, which is a form of operations research. And so you have this kind of interesting dichotomy of people that are bringing in insight from other fields, but they're bringing it in a relatively conservative industry. And I think that makes it a little bit difficult just in general. But to answer your question, how can we benefit from making things smarter, more connected? I think that we're going to have to, because cities have to be smarter. We need to integrate IoT to monitor transportation systems. It's not just transportation, it's power. We're all kind of interconnected. Look at, for example, now I think this is a really interesting time given the situation with COVID-19. Everybody's working from home. So now what does that mean in terms of the residential demand? Residential demand has increased quite a bit because now people are not away from their homes. So having a more connected home is very relevant right now, not only in terms of your appliances and making your home energy efficient, but creating home office spaces, being connected in a way that you can still maintain the pace of work life. We now have new threats. We now have, as the climate is increasing, the temperature is increasing. We're having climate change. Climate change is something we can no longer deny. It's here. It's creating kind of an environment where we're in territory we've never encountered before. We have new bacteria, new viruses, animals are moving, shifting. There's this state of flux that's going on in the world, and it's going to change what homeostasis means for us as a kind of a species, as a for the entire world. And having information, having data is going to be essential, because from that data we can make inferences as to what sort of decisions that we need to take. And having sensory systems that take that information in, do the number crunching for us, and aid us with our decisions are going to be extremely important. So I think the field of autonomous systems is only going to grow. We have a lot to work on. As of now, there's this whole movement. So I work a lot in machine learning, and in machine learning, there's a lot of applications in robotics. Yes. And there's a lot of smarts that can be built in to a lot of these devices. And that's kind of like where I stand. And I think that there's going to be significant growth, because there's a difference between doing machine learning in simulation and making decisions based in simulations, and a huge leap between that and going into the realm of, okay, now I'm creating an autonomous vehicle that now has to drive in the environment where there's pedestrians, there's cyclists, there's traffic. There might be an event going on at a particular location. It might be summertime. There might be a power outage. There's like all sorts of variables that you need to take into account. And the more connected we are, and the more information that's out there, I think that that's going to help human beings, but more importantly, autonomous systems. So the whole idea of autonomous systems is really to not have to, is to basically make our lives easier. Absolutely. There are going to be decisions that we as human beings want to be the primary sort of stimulus for, but there are also decisions that happen kind of on a day-to-day basis that we could benefit from having a machine do for us. Yes, because absolutely. it might be something very, very trivial that we don't want to deal with. So we want to save our mental capacity for something that might be more important. So I think having a reliance on those systems, it's already today. I mean, we have Siri, we have all sorts of devices that we use to assist us. So I think it's just going to grow.
Yes, it will grow. There is no doubt about that. And all different variables that you mentioned, all different industries, like, if you talk about the smart energy industry or home industry, smart homes or smart enterprises or smart, vehicles or smart cities, they all are, going to be connected. And for each of them, there's so much data that's going to be generated, and there's so many decisions that we need to be taken. We humans, it is not possible for our, processing power to process that much information that rapidly. Mm-hmm. So yes, autonomous systems are going to be absolutely essential and fundamental as we try, to develop all this, a whole new ecosystem, that revolves around the autonomy. So if you are visualizing, I mean, you are a developer, you are developing solutions, autonomous solutions. So as a developer, if you are visualizing how this entire autonomous ecosystem will look like, if we are thinking from a perspective of, everything that revolves in not only cyberspace, but also geospace, like, what happens on the roads, what happens in the, homes or enterprises, or what happens in aquaspace, like, in the water, and what happens in space, all these cyberspace, aquaspace, geospace, space, everything is connected. So as we visualize the nature of the autonomous systems, that we will need to develop in the coming years, because there is not a single initiative that would just be focused on only in one area. Internet connected computers has connected everything, aquaspace, geospace, cyberspace to space. So even for internet, we everything is connected. So as you visualize all these autonomous systems that we will need to define and then design and develop, how do you see this autonomy requirement evolving in the coming years, and how do you see the development, variables or development players? Do you think everybody is working in silo, or is there a need for collective vision or collective, at least brainstorming is required so that we develop the right pieces of all this autonomy that is around us?
So I think there is definitely a move towards collective vision because I can benefit from the domain knowledge of somebody else. I think that's always the case. You need to have a kind of a collective cohort, if you will, of people that you can work with for any particular problem. You also need to be very versatile because the problem parameters are going to change quite a bit. So having the knowledge of implementing a system is not the same as having knowledge of a system. For example, COVID-19. If I had to model the spread of the disease, I would go and I would consult biologists. I'd consult medical doctors. I would consult mathematicians, statisticians. There'd be a lot of people that you would need to consult that have their own expertise and very individual research goals that are going to be united for one common application. So I think it is extremely important to not be siloed at all. I think that that's going to be to your disadvantage at the end of the day, and that you really think of attacking a problem on really a global level. So I actually do talk to other academics who are not in my school or not in my area that I would trust and consult for any particular problem. And I think that being open to that is really important to address today's problems. You need domain knowledge. You need to have somebody who has highly specific domain knowledge to then take their ideas and apply it towards something. And it's not going to be perfect. I think that that's something else that people need to look at. The best problems to solve are really the simplest problems. If you can solve a simple problem, if you can dilute a problem down to something very simple, I think that you can build from there. And to get there takes a lot of knowledge.
Yes, yes, definitely. There's a need for a lot of knowledge, a lot of collaboration and cooperation, because these problems are so big for any one, individual or organization or country to solve on its own. Yes, of course, eventually, even if one country wants to do it on its own, eventually they'll be able to do it. But the amount of time that it will require to solve that problem, we can minimize that and we can shorten that by everybody working together. But at the same time, there's also this competition going on, especially if you look at the sectors like AI and autonomous systems, there's a huge competition, especially between India and China, between US and China. These two countries are competing, very aggressively, and a lot of, there is a lot of distrust between researchers and developers, and there is a lot of not sharing of knowledge, and information has stopped. As we see in COVID-19 also, we still do not have enough information about what actually happened in Wuhan. China has not shared that information, so there is a lot that is going on in geopolitics, especially with the emerging technologies. And if you look at the autonomous systems, there are automatic systems and there are autonomous systems, and automation has happened for many years, but autonomous systems that we are trying to develop, and they require understanding of how this system that we are developing will operate, or in unpredictable environments, because not everything we can input into the information, because we don't know everything that could happen as these systems go through unpredictable environments, like for example smart cars. we don't know what kind of obstacles or situations the smart cars are going to come across. So for every situation, how the car should, take a decision, those things, not everything is predictable. So when you are trying to develop solutions for these unpredictable environments, and developing an autonomous system for such unpredictable environments, irrespective of whether that is a solution for cyberspace in security area, or whether it's a smart car, or whether it's a smart city, or UAVs, or any kind of drone, any kind of autonomous system that we are trying to develop. So how do you define, design, and test these unpredictable environments as you design and develop these autonomous systems?
So the first step that you usually take when you're designing any kind of system is that you run in simulation. You run in simulation and you try to take into account certain variables. So I tend to use probabilistic models for that. So there's different techniques that you can use. Within machine learning, you can use different kinds of learning. The kind of bottom line is that when you initially come up with a concept, you need some prior knowledge. And I think that's been kind of the limiting factor for a lot of work. I don't want to generalize too much, but essentially, for initial ideas, for initial prototyping, there is a reliance on data. And having data requires that you have the trust in that data, that it not be quote unquote biased, right? Now, from experience, we've seen that there is actually bias in data. A really good example of this is, for example, so I had a colleague of mine working on galaxies and kind of mitigating the bias that's in the classification of galaxies. So we tend as human beings to be right-handed. And not only that, but in the past, being right-handed versus left-handed was associated with, being better than something. So someone was more religious and more pure, more holy, that was right-handed versus left-handed. And so my colleague did this work, and he found that there was an inherent bias in the way that people were characterizing galaxies, that people tended to characterize the chirality of galaxies as being right-handed because they had a bias towards being right-handed. So if you design a system on information that's inherently biased, you're essentially creating a flawed system, and then you release it out into the world, and you have this training period where you're utilizing this sort of false information, and it's out there in the world making decisions based on false information. In fact, this was one of the things we saw early on. I think there was a Microsoft chat bot that they made that turned out to be extremely racist.
Yes.
Things like that. Like, it learns from bad data, and having kind of more like a wide variety of modeling approaches, I think is one way to solve that problem, to reset calibration points. So I'm kind of in favor, but there's a big leap. There's a big leap between, so I work primarily in reinforcement learning. Those are the techniques that I use in reinforcement learning, kind of utilizes information that it's gathering in kind of as the system progresses to update its current model of the world. And I think having systems like that incorporate sort of feedback mechanisms, you can see this in kind of recurrent neural networks as well, is going to be more and more important. But then there is this issue of, how do we put that in the real world? Because we've been modeling and doing all these things in simulation, but putting it in the real world is a whole different ball game. And I think that just comes with experience. It's a difficult thing to answer because, again, it depends on the application. It depends on what it is you're trying to design. There are trade-offs that you have to make in any sort of project. What do you trade off to meet a particular specification or end goal? Like, do you care for precision? Do you care for some other outcome? So those are things that need to be weighed by kind of your goals. Do you have in mind for a particular system? I think that's probably the most important step, is when you're initially creating a autonomous system, is, okay, what is my goal state? What is the thing that I want to regulate? What factors are important? What factors can I trade off? And that's a hard decision. That in and of itself is inherently biased. So you could argue that all systems are biased, but then you want to create systems that will alleviate some of the stress in people's lives, to give them more time to do things that are more enjoyable. So.
I agree with you. I think it's how we look at things. Even there is one single fact, but two individuals can, look at it from a very different perspective. Yeah. They may form different opinions. So this is inherent nature. Even quantum physics, I think has come out when saying that there is everything. Even every particle. Even though we think it is like this, how it is viewed, and it's how the different it's entirely and especially when we are as humans, it is very, very complex how we evaluate things. So as a developer, as you define all these variables and as you work in reinforcement learning, what problems you face the most? What are the complex challenges for developers like you who are trying to develop some systems or advance the machine learning so that we can develop better systems and we can solve bigger problems? What complex problems you are facing that needs to be solved for us to take a step forward?
I think one thing is scalability. Again, taking something that's you've created in your toy world of simulation and utilize it in a real world system. So I think that leap from implementing the software framework for it in simulation versus actually implementing it into a physical prototype is quite challenging. Scalability also in terms of the amount of, like we mentioned earlier, the amount of variables that you may have taken into account in your sort of conceptual framework in simulation is going to be different than reality. Maybe those variables have a larger or smaller probability of occurring than you actually took into account originally. Yeah. So things like that can be very tricky. I think that's one of the main issues for reinforcement learning in applied systems. I think that's why there's been such great success with neural networks and other approaches to sort of in vivo prototype systems, is because they don't face that sort of leap that you have to make. So I think that there's a lot of work that needs to be done in this particular area, and there is work being done. There's a lot of work being done out of Stanford and in Berkeley, where they're incorporating different modalities of reinforcement learning, imitation learning, different kinds of forms of research into a laundry folding robot, or into other kind of home robots for assistive technologies. So there is a lot of research, a lot of work being done. But again, they're being done in very isolated cases. They're being done for very, very simple tasks. Yes. And they've been proven and shown to be very successful in those very simple tasks. But how can you now scale that up so that your agent, your home robot, your personal assistant can do a variety of tasks besides picking up an object and placing it somewhere?
Yes, very true. Now, you made an important point that, what variables we define that would, be based on what understanding we have at that point, and all the systems will operate based on that. But let's say we define a system, design a system at this point, and we have defined certain variables, but then and we deploy it, and in the field to, and we in operational, and then we realize that there is an important variable missing that we need to incorporate for the system to be performing optimally, or for us to get the results that we are hoping for. These any of these systems are, do you design it in a way that they are just closed, that we cannot change the variables or add the variables, or is it open system that if we come across a new idea or a new variable that needs to be incorporated into the system we design, that we will be, while it is operational, we can change that, and we can make those changes? Is it possible in the systems that you are developing to make the changes in real time?
So the sort of systems that are being developed in an academic atmosphere are significantly different than what they do in industry. So in industry, you would have to make your whatever it is, your product, your agent, you'd have to make that extremely versatile, and you'd have to follow basic software engineering design principles to allow for that product to receive updates, to get updated, to improve. You might have an initial beta version, and then you're going to have different versions that are going to roll out, and you can install firmware or updates and that kind of stuff in an industry standpoint. In an academic standpoint, you're dealing with a very specific problem. Typically, the problem is usually specified by the person that's interested in funding that problem. So your source of funding kind of changes the focus of your project to what their goals are, and it has to align with your goals essentially as a researcher. So it's a very, very different set of environments you're dealing with. In that sort of situation, you're not interested in pushing out a product and updating the product and making it better and having more bells and whistles to make some kind of bottom line cash flow. You're interested in sort of a proof of concept. How can we help society? So I was essentially backed by the energy, right? The Department of Energy. So they're interested in this work. So they're interested in a very energy efficient sort of perspective, creating agents that can improve energy efficiency, that can improve smart grid technology. And so that's where residential demand response becomes a natural application for machine learning, for autonomous control systems in that perspective. In industry, you have to have something that can change, that's fast paced. So in order to design something like that, you need to not only come up with an initial idea, an initial prototype, you also have to take into account what it is that your customer wants, and then how to apply those software design principles. How can we make our product adaptive? How can we update it? What kind of methods should I use? What kind of agile methods should I use? And water flow or any of those kind of design modalities that they use. I used to teach software engineering a while ago, so I probably am butchering a lot of the terminology. But you have to use sort of those principles if you're looking at it from the side of industry.
Yes, no, absolutely. I hear you on that, because, I'm thinking from security perspective, because all these autonomous systems that we define, design, and, deploy in the field, what if, suddenly, we are fundamentally shifting the responsibility from our decision making to, and let the machines, take control, and let them take decisions. And what if, suddenly, it decides to not do what we have defined them to do, and go off, off track and we have to shut off those systems, then security comes in, right? And how are we going to shut off those systems? That is the holy grail of the question that everybody is thinking about. That what if autonomous systems it just goes off track and we have no way of controlling? Then how do we? That's why everyone I talk to, I ask them, is there a backdoor you are keeping? Is there a way you are still keeping control that we can modify the behavior of these systems, even if we deploy them in the field, so that we will have some control, even if we are not actively doing anything to control the system. But if we need to, we can take control of the system. So that's what I would like to ask you also, because because you are developing these systems that involves the smart energy and smart homes and all these smart cards probably you're working on, and any of the initiatives you're working on, that if we need to take control at some point, will we be able to?
I think that that's the main driver for a lot of systems, is that you want to, and the same for my system, you want the consumer to be in the loop. The consumer is part of the design of your system. So they need to have overriding power at the end of the day. And you see this with Tesla, with their car. The autonomous capabilities of their car can be overridden by the driver at any given time. And that's kind of been the movement of where autonomous vehicles have gone. If you've noticed, the design of the vehicles haven't really changed. The proposed designs still have the driver in the driver's seat and the passenger. Now, the driver is not going to take on that much of an active role, but if they need to, they can essentially override the system. Yes. For my smart home, the consumer is constantly giving feedback as to their comfort level. And this can be in the form of a dial. Maybe they don't like the current settings that the energy management system is on. They're annoyed of it. They're going to turn some dial. And that dial is now going to change the probabilistic models that the energy management system is going to utilize in the future. So there is this concept of how can we automatically gain sensory information and make decisions, the system on its own, but also include the consumer as part of this. And I think that that's where a lot of our autonomous systems are heading, is that the human being is still the main component of the design. So they're still providing feedback. And then that feedback gets used as another data point that you can then push into your model and update your model parameters. So that's really essential here. We don't want to have like a robot apocalypse where they're all just taking over and they just go and they're off calibration and they just kind of go on their own. That's far from happening. And that was actually
no, we don't want that. We want the robots though right now. If you're looking at it, in this COVID-19, shutdown where nobody can come clean your homes or cook for you or, do laundry or yard work, I think we do need robots, If do you see any development happening in those home robots that can take over, the day-to-day, task for
Yeah, so most of the work for home robots, is being done in Berkeley and in Stanford, and a lot of those home robots, they, like I mentioned earlier, they do a very specific task. Yes. So right now they can only do maybe one task. You can buy a really expensive robot and it can fold your laundry. It can put the dishes away for you, but it will do only that one task. It won't feed your cat. It won't cook for you. So there's a lot of work that needs to be done in that aspect. Now, I think in medicine, robotics has been really big. You still have the doctor, the healthcare professional in the loop, because that's extremely important. So we've seen advances in robotic surgery. Now, because a lot of healthcare workers are unfortunately getting sick, there's a need for how can we automate healthcare and to what degree can we automate healthcare? And even in those environments, you'll see a robot go into a patient room, and there is they're basically in a video chat conference call with a healthcare person, a healthcare, like a doctor or a registered nurse. And so having that sort of situation is really important. Now, I think the thing that's really difficult in the situation now is the lack of information. And there is information that's out there that's provided by the CDC. There's information, there's updates that are happening on a daily basis, but it's not enough information to make inferences on the level of contagion in a particular area, high-risk individuals. There's a lot that needs to be done, and that's not really anybody's fault. That's really because we're dealing with a new sort of crisis. COVID-19 relies on PCR testing, and that kind of testing takes a long time to complete. So there's also the lack of availability of testing, of resources. And so this sort of, I feel like I want to help. You want to help as much as you can the cause, but at the end of the day, it's the healthcare workers that are really doing all the work. So even the coolest machine learning tricks, the coolest robots, and none of that is going to really be available to address this current problem in time. So at the end of the day, you get kind of shaken up by all this. And yeah, there's really exciting emerging technology that's going on. But given the current situation, it's really the most simplest problems, right? Is like how do you address the simplest problem of supply? How can you provide, protective gear for medical staff? How can you roll that out quickly? And a lot of it, the obstacles that we're facing are a lot of, politics, the market, economy, things that people have invested in before. There's actually, and there's no way to foresee what could have happened. I mean, there's always scenarios that you think of, pandemics or something that were usually very common before the invention of modern medicine. And again, now I'm like trekking into a realm that I don't have any expertise in, but I think that at the end of the day, yeah, it's going to be more important. Will it address today's problems? Probably not.
Probably not. And I hear you on that. I hear you on that because the way we have designed our systems, I would say that we are not only facing pandemics of COVID-19, we are also facing a pandemic of China dependency because everything, if you talk about the mask or ventilators or everything was manufactured in China, and China comes to a standstill. We all come to a standstill because, the supply chain, the entire supply chain depends on manufacturing in China. So we don't manufacture gloves, we don't manufacture our mask, we don't manufacture ventilators. So if we are not manufacturing any of our basic needs to protect even our healthcare workers, and we depend on another country that is hit, where the outbreak emerged. So it is not only the risk of, getting the virus on, even if let's say we try to get the products from them and we continue getting from them, we don't know if the products that are coming to us are not already infected by the virus because the workers, this is, a pandemic. It was a broad epidemic in China before it happened in other countries. So we have a dual, risk here, if we get the products from them, whether it is coming, in sterile condition, whether the virus is in that or whether, we can depend on them. So there are many, structural changes needs to be there in the system. So yes, like you said, we may not be able to do everything that we want to with this current crisis, but we will have an opportunity and we should have an opportunity to define resilient systems. So in future, if this happens, and especially, this is a natural pandemic, we very likely will come across in our lifetime another man-made pandemic, because bioweapons are going to be easy to develop with the advances in technologies that we have. So we will need to be prepared, so we will have to create resilient systems. And yes, the point you made about the healthcare workers, they are being hit with the viruses. And I was thinking about it, what actually they are mostly focusing their time on testing, and keeping the patients comfortable by giving them oxygen supply, because most of the problems are about the breathing, right? So everybody's lungs are collapsing. So all that can be trained, robots can take over that, if we train them. If we have robots ready, then they can make sure testing they can do, they can make sure that they also do the oxygen supply, the ventilators, and mask and all that, all those tasks, the ones that I'm seeing, I think they can be automated, giving medications and all. So I think we will have an opportunity to develop very resilient systems, once we are past this, once we survive this. And I'm sure we are going to survive this. And there are a lot of people working on this, but yes, we have to develop better resilient systems. And this system of dependency, the whole world's dependency on China to get their masks, to get their ventilators, to get their gloves, is a very stupid system. We cannot depend on one country to get all our supplies. The entire world supply cannot depend on one country's manufacturing. So yes, we will need to decentralize manufacturing. We will have to use 3D printing, digital additive manufacturing, all these technologies we'll have to use. We'll have to come up that we can quickly print the mask that we need, we can quickly print the gloves that we need, we can quickly print the ventilators that we need. We'll have to use the technologies that we have. And machine learning can help us so much. These AI, we will be able to predict the outbreak right when it happens. So we will be able to develop very good systems that can give us global alert that there is an outbreak happening in certain area, so we quickly contain that area, so the entire world doesn't have to go through that. But having said that, we still have to work towards that. What would you like to tell our global viewers and listeners, especially your research where you are looking for cooperation, or where you are trying to inspire students to do something that bigger than themselves, or bigger than profits, but to contribute towards the future of the humanity? What would you like to tell them?
So, well, I actually want to go back to what you were mentioning earlier. I don't have any political views or any sort of particular thing that I want to look at, but I do want to mention that China has actually made a lot of their data available, and they've also contributed to the situation in Italy. So I don't think it's fair to blame any particular country for the current situation. I don't think that anyone could have I mean, it's a pandemic. Everybody's dealing with it. The whole world is dealing with it. So I think that what we're seeing right now is actually really beautiful, because you have groups like Helpful Engineering, you have groups that are working kind of across the country lines, across nations, to kind of come up with solutions that are making their 3D printing, like their files available, that are making a lot of contributions to open source. So, and those are not necessarily, only one group versus the other groups. I don't want people to think that they should be paranoid about, geopolitics as they stand. There's actually a lot of collaboration that's happening between academics, and those academics are from China as well. A lot of doctors there's been a lot of papers that have been published out of China. They were the first to do the DNA sequencing for the coronavirus. So I don't think that we need to blame any particular country for the situation. I think what is happening is really unfortunate, but it's also bringing out, there's positives that are coming out of it. There are people that are working to such a high degree of collaboration. They're working around the clock, and they're volunteering their time. You have developers, you have chemical engineers, you have doctors, you have medical workers, you have all sorts of people that are working around the clock to kind of not only assist directly with COVID-19, but assist in how life has changed for us. So the IT professionals, the people that are working on server systems to accommodate our talk, our Zoom meetings, our Google Hangouts, people who are being resilient to try to teach classes online now, especially classes that are really difficult to teach online. Teach a physiology lab online, how to do an organic chemistry lab online. So I think that instead of, trying to investigate and put the blame on any particular policy or any particular situation is really not productive. And I think that students, how they can contribute and how the future can contribute is to really stay informed, stay concerned, and just work really hard. I think that staying informed and being concerned, you're always going to be interested in the benefit of other people, in the benefit of yourself. I think that that's really important, that you think about a global whole as opposed to yourself. And I think that, even in terms of research, you have a lot to benefit when you're working in a collaborative environment with other professors and other people from other places who have different perspectives and domain knowledge than you do just by yourself. So I think those goals are really important. I think also right now, instead of doing nothing at home, you have an opportunity to learn an essential skill.
Yes.
And I think that we're not awarded opportunities like this. It's unfortunate because there are people that are suffering. There are people that are high risk. I have family members that are high risk, that they need to stay at home confined. I can't really interact with them. And it's hard, but it's also a really unique opportunity to learn a new thing, to learn programming, pick up a programming language, take a machine learning class, go take a class on Udemy. There's a lot of open platforms that you can use to educate yourself. Not only that, but now that education is moving online, you have really great institutions that are offering their courses. Now, MIT, Stanford, they all have open courseware, but now you're getting even more open courseware. Take advantage of that. That's a really, a great opportunity. Now, I know that's really difficult. Not everyone has access to internet. There's a lot of people that rely on their part-time job that they no longer have because of COVID-19. So, being resourceful in others is really important. But I think just making sure that you're interested, that you're concerned, that you're engaged, I think that that's going to be what makes my life fulfilling.
Yes.
So hopefully that'll make other people's lives fulfilling as well.
Absolutely, absolutely. While this is a time of great difficulty and a lot of challenges are in front of us, it is also a great time to bring the best out in each one of us. And like you said, we have to collaborate and we have to make sure we come up with effective solutions so we can put this crisis behind us. So thank you so much, Nadia. Thank you so much, Nadia.
You're welcome.
For participating in Risk Roundup today. We appreciate your thoughtful insight on autonomous systems, and our global viewers and listeners would benefit tremendously from the information you provided today. And as a result, this Risk Roundup dialogue has been of service. We thank you for that. So Risk Roundup is a strategic security risk research platform and community, and our strategic security community and ecosystem is the first and only cross-disciplinary and collective community that is made of top scientists, security professionals, researchers, thought leaders, entrepreneurs, philanthropists, policymakers, and academic institutions from across nations collaborating to research, review, rate, and report the strategic security risk facing the future of the humanity. Add your voice to risk groups. And until next time, I'm Jayshree, host of Risk Roundup, signing off. See you next time. Thank you.